First, an action potential is sent by a motor neuron to the sarcomere. The sarcolemma receives the signal through neurotransmitters that travel down the T-tubule. The action potential is then sent through the sarcoplasm to the sarcoplasmic reticulum. The sarcoplasmic reticulum contains calcium that is needed in the next step of muscle contraction. These are noted through green beads. The calcium is then released from the sarcoplasmic reticulum with the help of active transport and ATP. ATP is hydrolyzed into ADP and PI. The calcium then binds to the troponin to disfigure the tropomyosin, moving it from the myosin binding sites. This allows for the actin to bind to the binding site of the myosin heads. On the myosin, there is ADP and an extra phosphate. This phosphate is released, allowing the myosin heads to bind to the actin. ATP is needed for the myosin heads to move into a high energy configuration. This causes the actin to move. The sarcomere shortens, causing the contraction. Then the myosin heads move into a low energy configuration at the power strike. This is when ADP is converted to ATP. ATP is then needed to break the cross bridge and to also relax the muscle. The M line remains stationary during contraction, while the Z line moves toward the M line during contraction. In rigor mortis, all the calcium is released from the sarcoplasmic reticulum, and there is no more ATP being produced to break the cross bridge, resulting in constant contraction of the muscle.